All right, so this first one says, a music group is expecting to sell their new CD. You guys don't even buy CDs anymore. Now all our music is digital. But they're going to sell these CDs at a rate of R of t. And so it is 20,000 e to the power negative 0.12 t. CDs per week. And it's something per something else because it's a rate of the CDs. So T is the number of weeks, and we've got the amount of CDs. How many CDs are expected to be sold in the first 12 weeks? So what we want to do is accumulate CDs for the first 12 weeks. So it's going to be integral 0 to 12 of this function. And that's literally it. And then you're just going to type it in. So we want to accumulate CDs sold for the first 12 weeks. So this is going to be math 9, 0 to 12. Again, if I type too fast, you can always replay this video later. So I'm trying to talk at the same time. I type too many zeros and pause it. If I slow down too much over the typing, we're not going to finish. So if I type too fast, I apologize. You can always rewatch the video and slow it down and pause it. All right, and yeah, I agree. Buying CDs and even vinyl. I don't have a record player, but that's cool because you like physically have it. I don't know. It's just different. I grew up with that, so I like physically having the music. Downloading it feels kind of like not real, I suppose. All right, so we're gonna type this in, and they said to the nearest thousands. This is 127,000 CDs. So that one is D. All right, so number 2 says we're restoring a beach. We're bringing sand back to the beach because it erodes, right? And so they're bringing sand back to the beach. This S of t, I guess S for sand, 65 plus 24 sine of 0.3 t tons per hour. Again, it's a rate, something per something else. So tons per hour. Now here's where they get you on this one. Time starts at 5 a.m. All right, so 5 a.m. equates to time 0, right? And they're asking us for how much sand is brought in from 7 a.m. to 10 a.m. So we're going to have an integral. It's not going to be from 7 to 10. And I didn't try this, but I guarantee one of these choices is the integral from 7 to 10. Like if you're not paying attention, I guarantee you that that's one of them, right? We need to fix this. We're starting at 5 a.m. So good. Thank you, Joseph. All right, so 7 a.m. is going to be time 2. 5 plus 2 is 7, if you don't think of it that way. And then 10 a.m. is going to be time 5. So we want this to be from 2 to 5. So that was kind of the tricky thing about this problem is you had to adjust the time because time started, like the story began at 5 a.m. Now, if they had started it at midnight, then we could have just done 7 to 10. It's kind of nice when they like start things at midnight. All right, but anyway, this is going to be integral 2 to 5 of S of t. All right, and I got 255 points a little bit, which is letter A. All right, this next one, they give us a graph. The flow of oil in barrels per hour. Barrels per hour. It's something per something else. That's a rate. Through a pipeline onto line is given by this graph of the following, which best approximates the total number of barrels of oil throughout the day. So we want to do an integral of this, which means the area under the curve. So what I would do is count up how many squares, like how many units or boxes are under this curve. I can't find the area exactly because it's not a shape that I can do like a triangle or a trapezoid or something like that. But if we're doing a rough estimate, so I have one box there, and then this would be 2, 3, 4. So roughly 4 like boxes filled in there. And then each of these is roughly a half. So this would be like a 5th box or unit that's filled in there. So I have 5 of them, and then I have to multiply that by how much they're each worth. And I know this is super tiny, but we're counting by 6 on the x-axis. So this dimension is 6, and then 100 on the y-axis. So each box is worth 600. So like this one's 600 and this one's 600. Like each of these are 600, and then the half ones are 300. And you're just adding that all up. And so it's going to end up being 3,000. So roughly 3,000. So that one is D. So it's just the area under the graph. It was the accumulated amount of oil. All right, number 4. Let me flip to the other screen here so I can read this. All right, so 4 says, at time 0 minutes, a tank contains 48 gallons of water. So this 48 gallons is your initial condition. So we're starting with 48 gallons of water. That's how much we've got to start with. From 0 to 4 minutes, water is flowing into the tank at this E of T rate. So that's the rate in. And then water leaks out at this L of T rate. And both of those are in gallons per minute. Again, something per something else. They are rates. So gallons per minute. How many gallons of water are in the tank at time 4? So you're going to take what you started with, which was the 48. Remember the M&M problem? Remember the gopher and the monkey problem? We took where they started and then added on their accumulation. Right, so it's 48 gallons of water, and then we're going to accumulate from 0 to 4, and it is the rate in minus the rate out. And so I'm going to type that in and get our answer. Basically, you just set these up and then type them in the calculator. All right, so 48 plus integral, not to 0 to 4. And then again, I have to switch over to the other screen to be able to read these. The E of T is 12x, and then sine of, we have a fraction, pi over 4x for that one. So 12x sine of pi over 4x minus, and then the L of T, another fraction, it is 6x squared over x plus 2. So the rate in minus the rate out, and then dx, and hit enter, we get our answer, 82.748 gallons of water. So that one is B. All right, number 5. Now this one's a little tricky. There's not a ddx out front, so we're not doing the derivative of this. We're going to actually do an antiderivative and then upper boundary minus lower boundary. And this is tricky because if there was a ddx out here, all you would do is plug x in, and I think that's one of the choices. Yeah, 3x squared minus 1. All right, but we're not doing the derivative of this. It's just this integral. So I am going to do an antiderivative, which would be t cubed minus t, and then such that 2 to x. So I did the antiderivative of what's in here, and then we're going to do upper boundary minus lower boundary. So if you plug in x, it's just going to repeat that statement, but just with an x. And then if you plug in 2 cubed is 8, then minus 2. And so this is x cubed minus x minus 6. So A for that one. All right, and then last one. We have a continuous function f that is positive and decreasing. All right, so positive means it's above sea level. So it's going to be above the x-axis. Decreasing means it's going down. So it's going to be doing something like this, just for a visual. All right, so it's above the x-axis and decreasing. All right, g is the function given by this accumulation function starting at 2. All right, so our accumulation starts here. Which of the following could be values for g? And then they have, a table for g of x with a 1, 2, and 3 in here. So let's do 2 first. If you plug 2 in for x, what are you gonna get? Like, what is our integral from 2 to 2? And yeah, good, nice job. I was hoping like for a lot of answers there. From 2 to 2 is going to be nothing. You didn't go anywhere, so you didn't accumulate anything. So we're going to have 2, 0. And actually all of them have that as a choice. So it's going to have to be 2, 0. Now if we do 1, this is our area for that part. And I just sort of made up this graph. I invented that. But if we go from 2 to 1, we're going backwards. So that result should be negative. So I don't know what it is, but it should be negative. So we should get 1 and then something negative. So I can actually get rid of these 3 choices. And we plug in 3, from 2 to 3, we're going forward, so this is going to be positive. That doesn't allow me to narrow down anything else. Out of these two choices, they both have -2 and then 0. So that means this amount would be worth 2. Both of these choices have that as a -2. Since the function is decreasing, this area is going to have to be less than this area. If the function's going down, we can't end up with something more. So out of the choices, this one has a 1 and this one has a 3. It's going to have to be the one that has a 1 there. Because again, the function's decreasing, so you're ending up with less. So that one is going to have to be A.